For billions of years, the sun has been our guardian, warming oceans and lighting the sky. But stars are not eternal. Deep inside its core, hydrogen slowly fuses into helium, releasing the energy that keeps Earth alive. Every second, the sun converts about 600 million tons of matter into radiation. This seems harmless across human history, yet on cosmic time scales it is a countdown. The same reactions that created life will one day erase it completely from the surface of our planet forever. The sun is currently middle-aged, about 4.6 billion years old. It has another 5 billion years before its final collapse, but destruction begins much sooner. As hydrogen in the core runs low, gravity compresses the center, making fusion faster. Faster fusion means more energy, and more energy means a brighter star. Astronomers calculate the sun already grows about 10% brighter every billion years. That tiny change slowly shifts Earth toward a hotter and more hostile future. 3 in roughly 600 million years, plants begin to suffer. Higher temperatures speed up chemical weathering of rocks, removing carbon dioxide from the air. Without enough CO2, photosynthesis collapses. Forests vanish first, then grasslands, then microscopic algae in the oceans. Oxygen levels drop. Complex animals cannot survive. Long before oceans boil, Earth becomes a silent microbial world. Life does not end in fire at first, but with suffocation under an increasingly bright sky. Around 1 billion years from now, the oceans start evaporating rapidly. Water vapor rises into the upper atmosphere where sunlight splits it into hydrogen and oxygen. Hydrogen escapes to space forever. Earth slowly loses its seas molecule by molecule. Clouds thicken. Temperatures climb beyond 70 degrees C globally. The planet resembles a humid greenhouse more than the blue world we know. Any remaining life hides underground near deep aquifers or in polar caves. After about 1.5 billion years, the last surface water disappears. Continents bake under constant heat exceeding the boiling point in many regions. The atmosphere becomes dense with steam and carbon dioxide, similar to Venus today. Rocks crack, minerals melt, and plate tectonics stops as the crust stiffens. Earth no longer looks blue from space. It becomes a pale orange desert world wrapped in thick clouds reflecting a much larger, brighter sun. But the true catastrophe happens later. Roughly 5 billion years in the future, hydrogen in the sun's core is exhausted. Fusion stops in the center and shifts to a shell surrounding it. Gravity squeezes the core dramatically, while the outer layers expand outward. The sun swells into a red giant hundreds of times its current size. From Earth's perspective, the sun will fill a massive portion of the sky, glowing deep crimson. As the sun expands, Mercury disappears first, vaporized completely. Venus follows, its atmosphere stripped and crust melted into glowing magma. Earth now orbits inside the sun's outer atmosphere. Even before contact, intense radiation heats the surface above 2000 degrees C. Mountains melt into lava oceans. The crust becomes liquid. The atmosphere blows away into space under powerful solar winds far stronger than anything in today's solar storms. Tidal forces then take control. The sun loses mass as it expands, slightly pushing Earth outward, but drag from the solar atmosphere pulls it inward. Simulations suggest Earth spirals slowly toward the sun. The sky turns from red to blinding white as the horizon glows in every direction. There is no day or night anymore, only a continuous inferno. The planet becomes a glowing ember orbiting inside a star. Eventually the ocean's remnants, atmosphere, and even rock vaporize completely. Iron melts, then boils. Continents dissolve into a plasma stream flowing behind the planet like a comet tail made of stone. From afar, Earth is no longer recognizable, just a trail of heavy elements mixing with the sun's expanding outer layers. Everything that ever lived becomes part of stellar gas. Finally, Earth reaches the sun's inner envelope. Gravity tears the planet apart. The mantle disperses, the core fragments, and within hours the last pieces disintegrate into atomic particles. No explosion marks the end, just gradual dissolution. The atoms that once formed mountains, oceans, and living beings merge into the star that created them billions of years earlier. After engulfing the inner planets, the sun becomes unstable. Pulsations throw shells of gas outward into space, forming a glowing planetary nebula. This nebula shines brilliantly for tens of thousands of years, visible across the galaxy as a colorful cloud. Inside it remains the sun's core, a white dwarf about the size of Earth but half the sun's mass, slowly cooling in darkness. Ironically, Earth's material helps create new worlds. Heavy elements released into the nebula drift into interstellar space. Over millions of years, they mix into molecular clouds that collapse into new stars and planets. The calcium in bones, Silicon and rocks, and iron and blood become building blocks of alien solar systems. Destruction becomes cosmic recycling. If distant civilizations observe our region then, they will not see Earth's history, only a faint nebula. No sign will remain of oceans, forests, cities, or species that once wondered about the future. Every trace of human technology, satellites, and monuments disappears long before the red giant fades. Even our radio signals fade into cosmic background noise. The timeline may seem unimaginably distant, yet the physics is certain. Stellar evolution follows strict rules governed by mass and gravity. Every sun-like star eventually expands, sheds its layers, and leaves a white dwarf. Our planet's fate is not unique. Countless Earth-like worlds across the galaxy have already experienced the same ending. Long before destruction, intelligent life, if it still exists, would need to leave Earth. Colonizing outer planets, moons, or entirely different star systems becomes the only survival strategy. The real danger is not sudden impact or explosion, but slow, unavoidable change written into the sun's nature from its birth. One day the sun will erase Earth completely, yet it will also spread our atoms across the galaxy. The story ends not with disappearance, but transformation. We were born from ancient stars, lived briefly around this one, and eventually return to cosmic dust. The day the sun destroys Earth is also the day our matter begins a new journey among the stars.